Number 5. Suppose a population of insects increases according to the law of exponential growth. There were 130 insects after the 3rd day of the experiment and 380 after the 7th day. Approximately how many insects were in the initial population? Okay. Well, what's the basic model we've been using? Based on the fact that it says increases according to the law of exponential growth. So what's my exponential model? Okay. Y equals CE to the KT, yes? And remember that does correspond to the, I'm trying to think of the form it was, dy dt equals k times y. So that came up a couple of times in homework there. So now, what's the pairs of information they gave us? There were 130 insects after the 3rd day and 380 after the 7th day. Can we make some ordered pairs out of those? At least that's where my brain thinks them through, is ordered pairs. So I'm going to say that there's 3, 130, and 7, 380. Yes? Now, the problem we come into is, what is it asking? It's asking for the initial population, which really means that it's asking for, it's asking for when, basically at 0 days. Keep in mind, that's also asking for essentially the C value, isn't it? C value is our initial value. And so we're not going to have an equation to work with right off the top of the bat. But, so, we're going to take our 2 ordered pairs we do have, and we're going to sub those in to get 2 equations. I didn't realize how good that one was. I didn't realize what a lead-in that one was based on Ethan using equations here. It's actually a pretty good connection. So if we fill this in, 3 and 7 are going to go in for T, and 130 is my, 130 and 380 are my Y values. So I'm going to say 130 equals CE to the 3K, and 380 equals CE to the 7K. We can't find C right now. We need to start off finding a K value. And, well, I don't know. I don't think until we have a K value, it's going to be difficult to find C. So, kind of the whole substitution thing. I'm going to suggest that we pick one of these equations, solve it for C, and then substitute it back in to find K. Does that make sense? So I'll even write myself a note here. We're going to solve one of them for C. It doesn't matter. And then we're going to substitute that one into the other one. And that will give us an equation to find K. Okay. Whoops. That is the technique I was going to take you on. So, we solved one of these for C. I'm just going to take the first one. 130 equals CE to the 3K. What is that if we solve that for C? Okay. So C is 130 divided by E to the 3K. Or how else can I rewrite that? 130 e to the negative 3k. And I guess you could leave it in either form. Based on getting ready to plug it back in, my brain says to use the other form, or to, make it so that we don't have the fraction. Okay, so now we're going to use the other equation here. Now we're going to use the 380. 380 equals, excuse me, what am I plugging in for C? 130e to the negative 3k is going in for C, and then it's C times e to the 7k.
You add them?
Okay, the bases are the same on the e, so yes, you can add your exponents. So then I have 380 equals 130 e to the 4k. Divide 130 over to the other side. And nothing else, I'm going to say it's 38 over 13. So I'm going to cancel my zeros. I'm going to say it's 38 over 13 equals e to the 4k. And this is where I'm different from what you're going to see in the answer key. I tend to leave it in fraction form, and I tend to leave it all the way to the end in fraction form and plug that into my calculator in the end. You'll see in the answer key, they do a lot of decimals. And so I will say my answers sometimes come up slightly different in this section because she's using rounded decimals, which I never teach to do that. So. Yeah, you can either think of it as undoing left, right, middle, natural log of both sides, but you end up with what? Natural log of 38 over 13. And when I do the natural log of e to the 4k, that ends up just being 4k, right? Because natural log of e to something, natural log and e cancel, you just have that exponent of 4k left. Divide by 4. And so dividing by 4, I mean, it's going to be ugly however you write it. I'm going to write it as 1/4 natural log of 38 over 13. Could you also write that as the natural log of 38 over 13 and then all over 4? Sure. There's no nice way to write this. Now, I can tell you I have a decimal written in mine right now, but that's probably just because I saw decimal in the answer key at this point. Okay? I don't feel like you have to have a decimal at this point. But if you're trying to plug it in the calculator and check, the decimal I have is 0.268159. I don't know if you plug that into the calculator or not. Again, in all honesty, I don't feel like I have to have it because I just keep this mess and I plug it into my calculator later. It's a mess whenever you plug it in, right? Okay, so officially we have a k value, right? Whether you write it as a decimal, which, and here's what I would do. If you write it as a decimal, that's fine, but I would keep that whole big decimal on your calculator, right? Yeah, I guess I don't want the parentheses. Then I assume that's the appropriate decimal. Okay, so what does our model look like now? We had this, yes. Now we know the k value at least. So I can at least say it's y equals ce to the, and I don't know what's best here, but 1/4 natural log of 38 over 13, oops, and then times t. Or write the decimal. Whatever makes you happier, right? Okay, what do I do to finish this up? If we're trying to find the initial population, we need what? When t is 0? Excuse me. Wait a minute. Okay. Sorry, for a moment I thought, oh, we'll just plug in when t is 0, but that doesn't work, does it? And that's where I got lost with myself for a moment, because I'm thinking, oh, t is 0, that will give me c, but I also don't have a y value to plug in with that, do I? So, okay, in order to find c, we have an equation representing the situation. We have 2 ordered pairs, yes? Should be able to use either ordered pair, put that ordered pair back in, and that will allow us to find c. Okay, I'm just going to use the first one here. So if I plug that one in, man, plugging in 0 sounds so much nicer right there. Okay, so if I plug in 130 equals c e to the 1/4 natural log 38 over 13 times t, which is 3. C is essentially going to be what? 130 divided by e to the 1/4 natural log of 38 over 13 times 3. Which really I could, what could I multiply that 3 into? I can multiply the 3 by the 1/4 and say it's 3/4, right? Which an easy way to punch in 3/4 is to say 0.75, right? So at this point, try your calculators, right? That would be what I would suggest. Try your calculators.
Can you just plug in
Into the C that you
the
found.
answer for C?
Because that's like the same thing.
It's the same.
So plugging in the k value into here. Yeah. Makes sense. It gives you the same answer you said?
Yeah.
It makes sense. I'm with you. I'm with you now. No.
Say,
No, I see that. That makes, and actually it makes it easier, doesn't it? Totally there with you guys. So. Oh, yeah, and even, okay. Why I went there instead of there, my brain wasn't thinking. Are you guys seeing what they're saying?
Yeah.
Because actually, if you look right here, 130 divided by e to the 3k, 130 divided by e to the 3 times k, it's exactly. If you'd rather do this form, then do that form. Yeah. Make it easier, not harder. Okay, what'd you guys get?
58.152.
Okay. Now, this is where approximately how many insects were in the initial population. It feels weird to say approximately 58.152 because that's not very approximate, is it? So, I mean, I get that I would, I get that I want to say 58, approximately 58 insects. However, it does say approximately, so I don't know if you can get away with rounding less. I don't think you would see it as approximately on an AP test. I think it would be how many, and then if they wanted you to say to the nearest insect, they would do that. Otherwise, always assume 3 decimals. Okay? Okay. Other than your teacher made that more difficult than it needed to be at the end, are we good? Okay. Then the last two are half-life, and you have several half-life examples in your homework. Based on the model we've been using, just different format of it, A of t equals A naught e to the kt, where A of t is the same as y. Initial A naught is the initial A value, so that's what we've been calling C. With k less than 0, then the half-life of A is natural log of 2 divided by k. And I will, if I recall, I'm going to kind of prove that. We'll talk about that whole natural log of 2 over k thing here in a moment, that is representative of half-life. Okay, so that's a connection you can make. When appropriate, you can, that is one that you can just sub in when you need to. But at first, if I recall correctly, we'll kind of look at it, step by step there. So, a zircon sample contains 4,000 atoms of the radioactive element 235U. Given that 235U has a half-life of 700 million years, how long would it take to decay to 125 atoms? Okay, chemistry, anybody? Isn't that what we're doing? So, okay. So, notice we're talking about decay, exponential decay, right? What's the model we've been using? And you can use this model if you want. I'm just going to be consistent with the idea that I've been using y equals c e to the kt.
So can we always use this model?
For exponential growth and decay, yes.
And all of these are exponential.
Yes, they should be. And I guess, well,
I saw the first one. I did the first one.
huh?
I did the first one on the homework, and I didn't know if that is because it doesn't say
Well, and I guess we're not using all of them on exponential growth, or we're not using this model on all of them, because sometimes they give us equations or give us information we have to use. So if it's anything that talks about growth or decay, use the exponential model there. Okay. Okay. Let's see. What do we know? The sample contains 4,000 atoms. So what is that? That is my initial value. Now, if that's my initial value, and we're just using this basic model here, now you start throwing in other pieces, you start adding, subtracting stuff. I can't do this. But if we're just using the basic exponential growth and decay model, and I give an initial value of 4,000, that means that's going to be my C value. Again, we start adding and subtracting other numbers, you might have to adjust that, but you can think that. We don't even have to do any work to find that. Now, what information do I know? Because I'm going to have some kind of like ordered pair or something here. There's a half-life of 700 million years. We started with 4,000. What ordered pair can you come up with? Are you seeing where I'm going with that? After the first 700 million years, what do we know?
2,000.
We're at 2,000, right? Because half-life, so it starts at 4,000, it has decayed to 2,000. Now, I'm trying to think. Okay, so if I just use 700 and write this as 700 million, okay, so 700 million years, and then there's going to be, what do we say, 2,000 atoms. Here's the deal. We can just throw in 700 million, or we can just throw in 700 and not have to put all the extra zeros. But when we get to the answer and it's saying how long, what do we know we're going to have to label our answer in terms of? Million years. And that throws us, that means we don't have to throw in so many. We can just say this is 700, 2,000. Okay? So, given all that information, we can work to find our K value. Okay, we know we can use the model of y equals C, so y equals 4,000 e to the kt. We have an ordered pair of time and atoms that we can put in to find K, correct? So I'm going to say 2,000 equals 4,000 e to the 700K, if you will. What happens when we divide here? 2,000 divided by 4,000 is 1/2 e to the 700K. Why is that 1/2? Yeah, and the fact that we're talking half-life, right? Okay, it should be 1/2 because we just, we're using that first ordered pair, and this is a half-life problem. Okay, keep solving for K. If you take the natural log of both sides, the natural log of 1/2, natural log of e to the 700K is just going to be 700K. And then K is going to be, bless you, natural log of 1/2 divided by 700. Or there's a decimal equivalency, right? Okay. Now, I think in my notes at this point, I just use natural log of 1/2. However, I want you to be able to go back and forth here. Review. It's just kind of a little side note. I'm putting it in the middle. But natural log of 1/2 is the equivalence of when there's division inside a log. That can be rewritten as 2 logs being... Oh, actually, wait, which way do I want to do this? Okay, we'll do it that way. A couple of different ways I can do that. So I can write this natural log of 1 minus natural log of 2. Well, what is natural log of 1? 0. And so this is really just equal to negative natural log of 2. I could have also done that with negative exponents. That was my midway thought there. Why do I show you this? I don't care whether you keep using natural log of 1/2 within a problem or negative natural log of 2. But what are you going to see pop up in the answer key sometimes? Negative natural log of 2 in place of natural log of 1/2. Okay, in terms of how you work, what you plug into your calculator, it doesn't matter. Did I answer your question in there somewhere, Connor? Okay. So, it doesn't matter to me what you do, but there's already going to be some confusion when you guys look at answer key for some of this. So I guess what I'm saying here is you could also write this as negative natural log of 2 divided by 700. I'm not saying you'd have to, but you could. Because anytime you see that natural log of 1/2, that is equivalent. Okay? I do have a decimal in my notes in case you want it. I have negative 0.0009902. And again, I'm not sure I'm even going to plug that in right now. But what I do know is I can write an equation. I'm going to write it over here. That is y equals, okay, C. C was 4,000 e to the kt. K is that value there. So, I can write it as natural log of 1/2 over 700 times t. It just gets hard to read, doesn't it? However you want to write it, you have to be able to work with it. And this is where maybe you want the decimal. Okay, that's our equation. What are we being asked? How long until it will decay to 125? So what am I doing?
Why is 125 solved?
We want to know basically question mark, comma, 125. So I'm going to take that equation. 125 equals 4,000 e to the natural log of 1/2 over 700 times t. Let's see, what does 125 divided by 4,000 do? Well, I never divided it in my notes. I just left it. So I know it's going to simplify a little bit because I know they're at least both divisible by 25, you know, but I never got around to doing that for whatever reason. Okay. If you don't like the number I'm using, then you figure out what you want to use. Okay. What are we going to have to do here? Get that t in the exponent, so we're going to have to take the natural log of both sides, right? So natural log of this 125 over 4,000 value. And I will say, if there is a nice easy decimal you want to use, you can use that too, right? Natural log of e is going to cancel it out, so we're going to have natural log of 1/2 over 700 times t. How do I solve for t? A couple of different ways you can write this, yes. Nice thing is we have big fancy calculators that you can plug in as much as you want, can't you? Okay. I don't know, Peyton, if you want to borrow a calculator to, you know, I don't know if you're wanting to try any of this or anything, but on this, you could write it as this natural log divided by this fraction, or you can multiply by the reciprocal of that fraction, right? So I could write it as natural log 125 over 4,000 divided by natural log of 1/2 over 700. I mean, it's messy, but here's the deal. You're plugging it into a nice fancy calculator, aren't you? It's doable. If you'd rather say that it is, if we'd rather multiply by the reciprocal, then it'd be 700 times the natural log of 125 over 4,000 divided by the natural log of 1/2. I don't know. Whatever makes you happy. Did you guys get a t value?
Mm-hmm.
What'd you guys get?
3,500.
Okay, and it's exact, isn't it?
Mm-hmm.
And it's exact because we've used the exact values. If you would have used it round in decimals, I don't think it comes up that way. Because I don't think, when I looked in the answer key, that it was exactly the 3,500. Okay, so 3,500, and then how would we need this to be labeled? Million years. And that is what? Before zircon would decay to 125 atoms. That is.
I'll still be around.
Okay. You let us know how that goes,
I
Ethan.
will.
Okay. Not that any of us will be here to hear that from you, but. Okay. We've got one more to go. Ready to talk about some hot chocolate?
No.
Too bad. Cup of hot chocolate placed on a table cools at a rate of, they're giving us a rate, yes? Where H represents the temperature of the hot chocolate and T is time in minutes. If the coffee was 160 degrees Fahrenheit initially, what will its temperature be 10 minutes later? And notice we magically changed from hot chocolate to coffee. I caught it this time.
Oh.
This time I caught it. Now, I think, if I remember, there's a coffee problem in homework. So my guess is she's doing some copy and paste and, you know. I'm guilty. You forget to change one little word. So I'm going to go with this is supposed to be hot chocolate, right? Okay. So, given dH/dt equals negative 5/100 times h minus 75. What do we do first? Multiply the dt over. Because our job is to try and separate the variables, yes? You want me to take 2 steps or do it all at once? Okay. So if I multiply the dt over, we're going to have dh equals negative 5/100 times h minus 75 times dt. What has to move? The h. And so if I'm moving that h, I'm actually moving the h minus 75. And I can just divide by h minus 75 because it's all multiplied, right? So I'm going to have dh over h minus 75 equals, and I'm going to leave the negative 5/100 and the dt there. What did I imagine?
That H is in the capital.
Yeah. When I'm doing my dH/dt, I'm like, why do I all of a sudden have a lowercase and an uppercase? I magically transitioned. Not sure why or how, but I did. Okay, we are ready to integrate. Well, do you know what is the integral of dH over h minus 75? Okay, natural log of h minus 75. Integral of negative 5/100 dt. See, I was trying to remember, do I have a plus c in the notes? I think I do, don't I? Okay. Now, if I'm trying to solve this for h, this is what I call left, right, middle. You've got other ways to get there, then that's fine. If I do left, right, middle, e to that right side is going to equal h minus 75, yes? I'm going to write it as h minus 75 equals e to the negative 5/100 t plus c. With that in mind, how are we going to reorganize that plus c? Do you remember doing this last week? And I'll take a couple of, in other words, I'm probably going to, you're going to see in the note, it's just going to jump all of a sudden. But if I take that extra step this time, e to the negative 5/100 t times e to the c, right? But then e to that c we can change to a big C, a K, whatever. So the more we do this, the more you're not going to see them put that step in there. Okay? It's just going to be magic and appear. And I'll be honest, some of that magic in the answer key caught me when I was trying to do homework. So if we solve for h, we're going to add 75. So h is 75 plus c e to the negative 5/100 t. So I have an equation here, right? And it matches with my notes even better. Okay, let's see. If the coffee was at 160 degrees Fahrenheit initially, what's that tell me? We have an ordered pair of 0, 160. And this is where I caution you, don't just assume that C is 160. And what makes it different this time? The 75. Okay? So this is where you actually need to use the idea of plugging 0 in, setting your equation equal to 160 to be able to find that C, which what are we trying to get to? What will the temperature be 10 minutes later? So we need a full equation. to plug that 10 in. Okay, and I say that because, guys, I got caught on this too. I still wanted to say, oh, hey, C is 160, moving on. But it's because it's not just this part right here. Okay, so with that in mind, if I use the equation H equals 75 plus CE to the negative 500ths T, 160 is 75 plus CE to the negative 500ths times 0. Well, you end up with e to the 0. E to the 0 is going to be 1. So we end up with 160 equals 75 plus C. And so C is 85. Okay. So now, if I write my new equation again, H, and I've just been writing H. If you look in the notes, you're probably going to see H of T. There's not a wrong versus right there. Okay, just throwing it out at you. So this equation is now 75 plus 85 e to the negative 500ths T. So we have a full equation, right? No C's or K's or anything like that left. And what were we asked? What will the temperature be? 10 minutes later. So what am I doing? Plugging in 10. 75 plus 85 e to the negative 500ths times 10. Did we get an answer? Yeah. I have 126.555 written in my notes. And what I have written next to that is our AP answer, right? Unless they give you any reason to go less than 3 decimal places. That's what we're doing. Now, what are you and I more likely to say? About 127 degrees, right? I couldn't remember what we were. Oh, it was oven temperature, or it was hot chocolate temperature, wasn't it? So, okay. So, either way, you know. Okay. Use those examples. Some of the homework questions go right alongside of them. Some of them, not so much. Some of them take a little bit of work. Okay.